And the last topic for this unit is looking at analyzing the equation of a quadratic function in standard form. First of all, we need to know how to find the axis of symmetry so that we can use it to find the vertex. Remember, the equation for standard form is y equals ax squared plus bx plus c. So when we look at this equation for the axis of symmetry, we see x equals the opposite of b over 2a. b is the coefficient of our x, and a is the coefficient of our x squared. To find the vertex, we simply take the x value that we get for our axis of symmetry, substitute it into the equation to solve for y. Our essential question today is, how do we analyze the equation of a quadratic function? First of all, we will find the axis of symmetry. This is the equation x equals the opposite of b over 2a. When we look at the equation, b is the coefficient of x, a is the coefficient of x squared. Remember, if you don't see the coefficient, you're multiplying by 1. Substituting those values in, we get the opposite of b. So if b were negative, the opposite would be positive, all over 2 times a, that coefficient of x squared. Order of operations says grouping symbols first. This fraction bar acts like a grouping symbol, so we need to multiply in the denominator first, and then we can divide. So our axis of symmetry is the equation x equals -5. Next, we will use that to find the vertex of our function. We simply take that x value and substitute it into the equation everywhere we see an x. And then we will solve for y. Order of operations, we will square the -5 first. Remember, when you multiply something by itself, it becomes positive. We can also simplify that 10 times -5 because it's separated from the power by a plus sign. 10 times -5 is -50, and then we have our plus 3. 25 minus 50 is -25, and -25 plus 3 is -22. So the vertex is, our x coordinate was -5, we substituted that in and solved to get -22 for the y coordinate of the vertex. And the last thing we were asked for is our y-intercept. To find a y-intercept for any equation, always we substitute 0 for x and solve for y. Again, following order of operations, 0 squared is 0, 10 times 0 is 0, and 0 plus 3 is 3. So the y-intercept is 0 for x, 3 for y. I'm going to show you a shortcut for the y-intercept. Notice we got 3 for our y-intercept. And notice in our equation, the one piece of the equation without a variable is 3. When you substitute 0 for x, those variable pieces disappear, and you're just left with the constant. We're jumping to example 3. We'll look at examples 2 and 4 together in class. Let's take a look at that one more time, starting off with our axis of symmetry. This is the equation x equals the opposite of b over 2 times a. Remember, b is the coefficient of x, so the opposite of 12 is -12. All over 2 times a is the coefficient of x squared, -3. Following order of operations, using this grouping symbol, we will simplify what's in the denominator first, and then we will divide our -12 by 6 to get a +2. So the equation for our axis of symmetry is x equals 2. To get our vertex, we take that x value and we substitute it back into the equation for x. So we had -3 times x squared plus 12 times x minus 8. Order of operations, we will square that 2 before we multiply. We can simplify that multiplication because it's separated from the first term by an addition sign. -3 times 4 gives us -12 plus 24 minus 8. -12 plus 24 is 12. 12 minus 8 is 4. So our vertex, we started by substituting 2 for x, and we solved and got 4 for y. And finally, our y-intercept, let's use that shortcut. When we look at the equation, all of the terms with an x will cancel because they're being multiplied by 0 when we substitute 0 in for x. The only term that will be left is the term without an x, and in this case, that is -8. So our y-intercept is 0, -8. If you want to try to find that information on your own, here's your you try question.